So this is problem set 75, and it's a focus on more on equation of the line and using specifically something called the slope-intercept method for graphing. And so I just want to kind of remind people about a couple things. So remember that from previous lessons, m stands for slope, and if you have a positive slope, really what that can be is, well, you can have a positive m value. In fraction form, it could be a positive over a positive, or the one that throws people off sometimes is if you have a negative over a negative, which we know from division rules that if we divide a negative by a negative, that gets us a positive value. So sometimes that can be a form that people don't recognize as actually being a positive slope. Now, if your slope is negative, it can look a few different ways, right? You can have a negative coefficient in front of your x value if you're talking y equals mx plus b. You can have a positive over a negative, and that would make a negative slope. Oops, meant to just put a negative there. Or you could have a negative over a positive, and really either of these three would qualify as a negative slope. So just kind of a reminder that some of these look a little bit different than maybe what you might expect. We're going to be doing quite a bit of graphing. I think ideally you'd be on some graph paper here, but I'm actually going to kind of do some quick rough sketches of graphs. So the first is asking us to graph y equals -4. And this is a nice example to kind of remind yourself of what graphing a solution actually means. First of all, I'm just going to sketch my x and my y and always label them. And really, you have to ask yourself, where is the line where all the values are equal, the y values are equal to -4? And if you think about it, down here on the y-axis, if I kind of go down here, down 4, right, the horizontal line that runs parallel to the x-axis is going to be all the points where y is equal to -4. So this would be 0, -4, 1, -4, 2, -4, etc. They all exist on this line. And I might even put that in a different color just to make sure that we know the difference between that line and the x-axis. You can also label it. It can be helpful. And there we go. Conventions, here's y equals mx plus b. We should be familiar with that. And again, I mentioned it up top, but our m value is our slope, meaning what's happening to the tilt, really, of our line. And the b is the y-intercept, or the place where the line crosses the y-axis. So what I'm going to do here is I'm going to graph a few examples where I'm going to specifically use this information, just the slope and the y-intercept, to sketch the line. So down here, we have y equals -3/2 x plus 3. So first and foremost, I can recognize that I have a slope here of -3/2. I know it's a negative slope, which is really important information, which means my line is going to be decreasing from left to right as opposed to increasing from left to right. I also know that I have a y-intercept of 3. So the way that I would use this information specifically to graph is that I would sketch my little coordinate plane here. I know that b is +3. So I know that that is where it's going to cross the y-axis. Put that in blue there. And I know that my slope is -3/2, which means that our line is going to be decreasing from left to right because it's a negative slope. And if we remember that it's rise over run, we could say, okay, down 3 to the right 2. So 1, 2, 3 down, to the right 2, and that would put my next point right here. And I could keep following that pattern. Add more in. Down 3, 1, 2, 3, to the right 2, 1, 2. And if you're on graph paper, this should be precise, but there it is. These should all be in a line. And there it is, and it's a negative slope because it's decreasing from left to right. Let's take a look at number 2. I'm going to throw in my little graph here. And I've got my x and my y. Should have done that on the other one too. I'll do it now. Here we have our m value is 1/2, positive slope this time, and our b value is -2. So that tells me that I'm going to have a y-intercept at -2, and that's where I'm going to start on the y-axis as I start to plot some points. So -2 is definitely where it's going to cross. And now I have a positive slope, which means it's going to be increasing from left to right. And so again, rise over run means that I'm going to go up 1 over 2. So from this initial point, I'll go up 1 over 1, 2, and that'll be my next point. I'll do it again, up 1 over 2, 1, 2, and there's a third point. Again, if you're using graph paper, these should perfectly line up. If you're not, like I am, they should almost line up. And there you have it. All right, one more. Y equals -3/5 x plus 2. What's my m value? Well, it's -3/5, so I got a negative slope this time. What's my y-intercept is 2, so that's where I'm going to start. So I'll put in some lines here. And so my first point on my y-axis will be 2. And now I've got a negative slope, so I can go down 3 to the right 5 for my next point, because it's rise over run. 1, 2, 3. To the right 5, 1, 2, 3, 4, 5. Plot my next point. Now, because I just ran out of space, I'm not going to plot another one. So I'll just connect these two. Sometimes it can be good to have a third point, kind of as insurance. And there you have it. Once again, I've forgotten to label my axes, so I'm going to do it right now, x and y. Okay. So with these, give them a shot with the practice problems. And then when you're ready, you can move on to, whoops, actually I forgot. I got one more. Hold the phone. We do actually now have one more example that I almost didn't do. Here we go. We got a graph x minus 2y equals 4 using the slope-intercept method. Now what you might notice about this one right off the bat is that it is not in y equals mx plus b. And that's a problem, right? Because we can't quickly identify our slope or our b value or y-intercept in this current form. But we do know how to manipulate equations. So what we're going to do is we're going to put it in this form, y equals mx plus b. And one of the first things we can do to do that is to isolate the y. So that's what I'm going to do now. Is I'm going to solve this equation. I'll subtract x from each side to start. Divide each side by -2, remembering that you have to divide the entire side by -2. And you get y equals -2 plus x over 2. I'll switch the order of those. X over 2 plus -2. And at this point, you might recognize, yeah, okay, this isn't quite there yet. But x over 2 is actually the same thing as 1/2 x. So that just clarifies what our b value would be. And now we've got it. We've got y equals mx plus b, and it should be pretty clear that our slope is going to be 1/2, and our b value will be -2. And then we're kind of just to those examples that we had on the page before, right? -2 is where it's going to cross on the y-axis right here. Up 1 over 2 is going to be the rule as dictated by our slope. Up 1 over 2. Up 1 over 2. And we connect those, and voila, we have done it. So now take a look at the problem, the practice problems out of your textbook. All right, you're in for a fun one for problem set 76. This is consecutive integers. We're going to be using some equations and some of our variables to kind of solve these interesting little number puzzles involving consecutive integers. And consecutive integers are really just numbers that come right in a row, right? So an example of three consecutive integers would be 2, 3, and 4, for example. So they're just kind of like integers that are right next to each other on the number line, right? So we're looking at questions like find three consecutive integers such that the sum of the first and third is 146. Now certainly you could guess and check on this one, and if you were in that kind of state of mind, you might, and you were asked to jump into a question like this, you could figure it out that way. But we are not just anybody, we're Algebra 1 students, and we know how to use variables. So if you think about it, if you let x be the smallest integer in your group of consecutive integers, if you let x be the first, you could write the next integer as being x plus 1, right? And the integer after that, of the third consecutive integer, could be x plus 2. So this is a generic way to write three consecutive integers. Now, what do we know about them? Well, we're trying to find the sum of the first and third being 146. So our first and third would be x and x plus 2, right? That would be the first and third. So it's saying the sum, when we add them together, is going to equal 146. So if we set it up this way, now we have a little equation that we can solve, and we can figure it out. So we know that we can combine like terms here, and now we've got something we can solve fairly easily here. And we get x equals 72. Now, what did we find out when we got x is 72? Well, we just figured out what the first term would be. So if the first term is 72, then the next would be 73, and the last would be 74. And that would be our final answer to this question. All right, we have one that's maybe a little bit more complicated down here, where we're going to find three consecutive integers such that twice the sum of the first two is 2 less than 3 times the second. Whew. Okay, well, the three consecutive integers part, we already know how to kind of set those up with using variables, right? So we know that we can use an n plus 1. I changed variables on you, sorry. You could have just as easily used x, but I like to keep things interesting. N plus 1, n plus 2, that's three consecutive integers. And it says twice the sum of the first two. All right, well, the first two are right here, n and n plus 1. Twice the sum. Well, the sum of these two would be n plus 1. To get twice of that, after I add them, I multiply them by 2. It's important that I have the parentheses on there because I want the multiplication to come after I add them. Twice the sum of the first two is 2 less than 3 times the third. Oh, 2 less than 3 times the third. So I got to multiply the third one by 3 and find 2 less than that. Oops. And the way you find 2 less than that is to subtract 2, right? And now I have an equation that I can solve for n, and if I can figure out what n is, then I can figure out the other consecutive integers. So I'm just going to go ahead and solve this piece by piece. I'll combine like terms here. I'll distribute the 2. And then I'll simplify the other side. It looks like I'm going to have to distribute my 3 here. So I get 3n plus 4. Subtract 3n from each side. And so I have n equals 2. And now, if I know that n equals 2, I figured out the first integer, and I can figure out the next ones by adding 1 to get 3 and adding 2, which would get me 4. And there we have it. So take a look at these practice problems, and good luck.